and maybe it will be better if we develop this oxy-fuel technology and then absorb 6 years into.
In fact, that is the oxy-fuel dust power plant. People are working towards this. Your direction is absolutely right. You have some limitations and you go to this one. But yes, that plant you are going to visit, it's oxy-fuel dust power plant.
While recycling CO2 and H2 along with oxy-fuel, while recycling carbon dioxide and H2 along with oxy-fuel.
Sir, in fact, I am not able to answer this question. I think we can discuss it because this is beyond my knowledge. So what I can do, I can get back to the technology guys and the chemical engineers, and I can know. I am a mechanical engineer and I am having a bit of limitations on the chemistry.
Because I am already recycling CO2 in my motorcycle.
So that's why I know, sir. That's why I have seen your presentation. So, really speaking, I am not the right person to comment on that. But definitely I will get back to you, sir.
So it is combustible. CO2 and H2 is combustible.
Sir, CO2 is at high temperature, it is dissociating to CO. CO is basically combustible. Absolutely, you are right. But how far is compared to the limitations and the visibility of this? I am really, sir, I am a too small person. I am a consultant and what my job is to assemble information, get a project going. Really speaking, what you are taking is a scientist's job and I am having my limitations. I am sorry. But definitely I will try to get the answers and come back to you. Thank you so much, sir. So anything else we go forward? Pardon, sir?
David's contempt me. The molecular bonding can be broken using radio frequency.
So I think the idea is good, but I don't have any knowledge on that.
Okay.
Maybe possible. Maybe possible. I think the ideas are really
Already
possible.
happening. Water, hydrogen oxide can be separated from water.
Next.
Why not carbon dioxide be separated to carbon and oxygen? Then reach it.
So ideally, yes. But let's see.
That has been tried on. There is possible.
In fact, one of the technologies we will be discussing now, how we separate the CO2s. Let's interacting. Yes, sir. Any other points before we go to the next phase? Okay, let's then go to the next phase, which is basically the. Now we will be going into a big boring section of this presentation. No picture, no discussion on nothing, only some figures and these things. And again, let us try to put out what we best we can do. We will try to discuss what is the CO2 capture technologies are using globally and what is the market condition for that. Now, first thing is that this is the first slide on assumptions that what we are dealing with. We are dealing with a flue gas, basically, which is coming from the power plant. We are talking about a relatively less partial pressure because if we are talking about the 15% of CO2 in all 100% of the flue gas, we are talking partial pressure of the CO2 is less. That we are assuming. Then we are talking about that the CO2 is available to us at 100 degrees Celsius or more because of SOx and acid concentrations. And then I think you have read the rest one. Let us talk about this. One thing is that all this process, capture process, needs to eliminate NOx and SOx. That's one of the limitations of the process and one of the essentials of the process, that this CO2 typically reacts back with the NOx and SOx. So it is very important it should be FGD and NOx free. So that's basically that enhances the cost of capture. That's one of the pre-assumptions. We are not going into NOx separations and FGDs, flue gas desulfurizations, but let us talk about those. Before we get the flue gas, we are doing these two things: removing NOx, removing FGD. Now, what do we do in the absorbent? So we have a flue gas. We need to get CO2 out of it. So we need an absorber which actually chooses CO2 CO2 out of the flue gas, and this molecule they absorb. What is the characteristics of these things? So obviously this should not react with any other gases, nitrogen and place of oxygen, monoxide and SOx and NOx. It will only act with CO2. So that the first and foremost criteria of this absorbent is it only chooses CO2 selectively. One of the examples we get amine, however there are different chemicals but all are patented. So even I do not know what is the composition, the real composition of a chemical absorbent. It's only the patented guys they know. But this typically the amines. Amine group, they capture CO2. And this is alkali amines. So if you are the chemical engineers, you know better than me what is alkali amines. Now, how do we absorb this? There are 4 stages of absorption. The first stage is basically we have to cool the gas, which we discussed. So if we are getting the gas at 100 degrees Celsius, fine. If we are not getting the gas, then it should be at around maybe 200 to 300 degrees Celsius, 180 degrees Celsius, 210 degrees Celsius. We need to cool the gas. Now one of the use typically till that we are using water and quenching it out because we had a limitation of acids, but nowadays of this Babcock policy in Germany, they have developed the plastic heat exchangers which are now increasingly being used to remove heat before we give it to the GD plant or cool it. So getting the maximum amount of heat out of it so we can use the heat some other application. Because whatever we get, we can take it out, it's money for us. Second one is that once we cool the gas, clean the gas, we have to get the mix it with the absorption column. So what is there? We typically, the CO2 is coming from the below, water is coming from the top. So this is where we are cleaning the gas and then it is fed into back bottom of a pack where we are getting the solvent. Solvent is getting actually absorbing the CO2, the flue gas is coming out. Then obviously it has some amine, so we must have some stripper inside that when the gas coming out, the gas is getting stripped out of amine and the clean nitrogen is going out. Now one of the questions come in future we are talking about instead of nitrogen plant, a separate nitrogen plant, can we use a CCS plant with a nitrogen producing plant? Which is basically used in the steel industry and other applications. Now one of the things instead, and think about how many nitrogen plants in India are operating. If we do a CCS plant, actually we can get removed basically. So this is another of the things we need to integrate a lot of facilities together. It is not always bad, it can be integrated planning should be there. Now once we get the CO2 from that absorbent, now the next phase is that you need to remove that CO2 from the absorbent. So that typical process is you have to use heat it up, then it will release that CO2. Now once we release that CO2 again needs to be cooled and pumped in. High pressure and clean, and you have to use for storage and first transportation and then storage. So that's the process. Let's get what is the line diagram of this process. We have obviously the boiler, blower, quench cooler, just like you said, absorber towel, and then from the absorber towel you get to the CO2 stripper, then cooling and water, finally initial compression up to 50 bars, and then final compressions up to pipeline denser, but it can be 170 bars to 200 bars or 220 bars. It depends on the reservoir pressure. Because each reservoir, how we are going to put the CO2 in differently. So it is having their own pressure and this pressure is adjusted to put it down. Whether you put it 1 kilometer down, 2 kilometer down, obviously the pressure needs to be as per the requirement of that condition. State of commercial development, because we promised each of the processes we talk about the commercial development. These family processes can be considered to be fully commercialized. 3 licensors, ABB, Fluor and MHI offer full design package. So tomorrow, if you want to go of this or go to this process, you don't have any other option but to contact these licensors. Either you develop your own technology or you have to buy licenses from them. So that's why in the next 10 years, if we can actually initiate, some of us initiate that what can be the absorption process, the technology, it's a huge money. We are talking about this as a $1 billion project. Now, can we develop the technology on our own and license it? If yes, absolutely fine. If not, BHEL needs to buy the license. We don't have any other option. That's why I really, Mr. Jawar is doing really a great job. I think he is, I will say, the light gear on this torch gear in this area. Because he is putting this thing in. Hopefully, within the next 10 years, if we can do it, we can save lots of money to our country. Okay, next. We talked about that typically flue gas phase. What is the non-flue gas phase? So first one coming is the potassium carbonate. So this is your chemistry period. So here again, typically KNO3, KCO3, they have a affinity of to absorb CO2. And typically here this is being used also. If you can see this, we are talking about where pure hydrogen and pure CO2 is required. Typically this process historically used this. So this is not again a new field of research. People used to use this. Again, these are fully commercial, where CO2 only in operations where pure CO2 stream is critical. So if we are talking about our CCS project, ideally we don't need it. However, this is where this is used typically in this capture process again in the food grade CO2. In the food grade CO2, obviously I don't need adulteration. Though we have adulteration in everything, we don't need adulteration in our soft drinks. Anyway, it's aeration. So there we need to have this type of technology coming in. Again, typically the process, source gas containing CO2, you compress it, then you have to refrigerate it. Basically condense it. The purpose is condensation, so you have different condensation temperatures. You take it out, then you have to first stage again refrigeration, it has multi-stage, and then you pump it out, send it 50 bar and above. State of commercial development. Now typically this is I think yes, these are the three again this is licensed Selexol, Rectisol and Multisol. So these are the technologies have been licensed with the trademarks. So even if you want, you have to develop your own technology or you have to buy it. You don't have other options to going ahead with this technology. And as far as the CCS, CC, carbon capture and storage is concerned, this technology we are not looking out. So this is licensed by Lugi and Grindel India has taken up Lugi. It is the other one is Uday. The other absorption technology that is used, which is absorption, where we are using metallic sieves, alumina or oxide, where we can absorb CO2 as a molecular form in the sieves, and then we actually heat it up to release the CO2. Which some of the things in this direction we are talking, but you are talking of the radio frequency which is much higher. But this is a technology at absorptions over there. Research has been done selectively, and this is typically once I saw one of the things you are talking about with the University of Wyoming, and there they are working on this absorption technology. So if Bindu is there, she can absorb this one. I Bindu, you are not listening to me, Bindu. So this is the absorption technology the University of Wyoming is working on.
One second, can you show it, please?
Yes, please. And by the way, we are giving the slides to Bindu and she will this thing. So anytime and any of the issues, please get that. We are not the master of things, but definitely we can try to resolve this out.
I think nobody is the master of everything.
Now,
All the type of traits, you don't have to really apologize. You know,
We are here to learn.
really speaking, sir, you are doing a real great job. You should be proud of yourself and your team. And I'm proud of the participants. Basically, just speaking, you do not know what you are doing. The other thing is that coming on the cryogenic separation, we have discussed about the different ways of CO2 is getting separated and then absorption, the capture. So again, this is commercial application. Again, it's commercial. It's a land-bound process, and it was originally patented in 1970. So we are talking about around 30 last 10, 40, 45 years. This is getting in operation. However, again, we are talking about the commercial scale CCS capture, carbon capture and storage application. This is not we are not going to look for this. Now, one of the things, this is important, which is coming out in the gas separation method. So here we are talking about the different molecular states. So we are talking about them. That's why using the partial pressures and where the molecule, because of the membranes, we separate CO2 and rest of the flue gas. However, the technology, yes, which has some promise, but not so much. On the area, it needs the process, the time it needs, it's quite, it takes more time. Now, one of the things, this is the gas absorption membrane, and it is patented by government. Now, here we are aware of the related research in this technology. It's worth watching, but still it is working. Now, so this technology now onwards will be going more and more. These are all in the research phase, not commercialized. Now, a few of the other capture technologies in the research phase. I thought I would be talking all of them, but then I thought, no, there is too much of time. So, that is on a solid solvents, then we have syngas absorption process, where we are talking about the gasification technologies. Natural gas separation sweetening, they are also using, because when natural gas is coming from the associated gas, so basically what happens in the oil wells, you get the oil out of these. You get associated gas, which is mainly natural gas and sometimes other gases also. And this natural gas, first one, there is a streamer where gas is separated from the oil, and this associated gas, which is further then processed, and this process is having, sometimes there is a high CO2 content in the natural associated gases. Because I know one of the gas reservoirs, we are getting 11% of the CO2 coming in. So what we used to do, we used to separate that CO2 from the natural gas and put the CO2 back into the reservoir. So one of the synthetic technologies this is used. One is that acid gas enrichment technology, because this is also again related to oil and gas industries. We have acid gas coming out of the gas processing plant. Out of this gas processing plant, we need to separate CO2 and use the rest of the gases for the value-added chemical processes. There we use some technologies over there, which is also used, but then those uses are very limited, specific. Sulfur recovery unit tail gas, there also we separate CO2. And obviously we talked about oxy fuel a little bit. And finally, the most promising one is coming out, which is chemical looping combustion. Now again, I am trying to put it in the quote. This is quote because I do not do much of this. So I am putting my hands up. Well, this is the quoted. So no my analysis. This is the chemical looping combustion technology. It is coming up with the European Union funded project where different technology suppliers and the chemical engineers, they got together and they are trying to develop a technology which can be very much efficient and futuristic Now they have got the initial success for this chemical looping technology. The process features 100% of CO2 capture, so no talking about this. Ready for sequestration, no NOx. And it is used, I'm reading it out because I'm not comfortable. Generally, I don't like reading from the screen. But it's there. So it's a well-established boiler technology with the CAPC. And CO2 capture cost reduction 40 to 50% compares to today's best practice. So this is a very promising technology. Let us see who are doing this. Just see the names. We have the US Department of Energy, UK Department of Energy also. We have Shell Global, one of the largest oil and gas companies. We have Alstom Power. Again, Alstom is the largest technology licensors for almost all the power manufacturers, boiler manufacturers, today whether it's the Doosan, whether it's the Dongfang, DHL, basically they are the licensors, Alstom. So these are the partners, they are working on the chemical looping technology, and not only me, I think few people in the world they know about these details, and they are not expressing that what is there, only they know it. But hopefully this will show us the promise. And this is the brief summary of flue gas licensors information. Hopefully this is important. That if we have different companies, then what is the say ton your CO2, what's the steam consumptions of their technology, electricity consumptions, say cooling water and the solvent loss. So this is the comparison of different suppliers for CO2 separation technologies and the specifications of this. So all of the projects you have, again you see gas turbines, boiler and say reformers. There are three types of technologies and you have different applications. So now the answer is that no one is the best in particular, absolute best. You have your composition of flue gas, you have your process, you have your capacity. It can be 100 ton or 400 ton or 450 tons. And as per that, you need to choose your suppliers. Or else, what BHKL should do, develop their own technology. Because we are talking about the huge base. We are talking about 400,000 megawatt or more in coming years. With similar steel from 54 million tons, we are expecting 106 million tons. Obviously, we are getting another growth, industrial growth. There is a huge opportunity to work on. Let's work on this. Flue gas sensor experience compulsion, and now this is not updated a bit because 2008 they actually installed the Nagarjuna fertilizers also 450 tons. And ABB, they put it in the 800 tons, however, this is not working that effectively now. So, till now, if I put my money on, personally, I would like to image check. In fact, that we did, the absorption technology from image check, and the rest of the things from Siemens. Again, whatever we discussed till now, there is a summary of this. Hopefully you can go through this at your leisure times, and please let us know. I think that's all from me now. Prasanna gave me a time of till 1 p.m. and I am finishing in just 2 minutes before that. It's right, Prasanna? So you have to honor my sense of time.
Yeah. Questions?
Yes, sir.
I take on cyclist. Sir, flue gas contains radioactive materials like thorium and uranium. I want more details about it.
Okay, sir.
Yesterday it is given to me.
Okay, sir. We'll details. You have my mail ID. You have my card.
Something about gas. The basic condition is there is no subsequent NOx. But that is practically very difficult in a power plant. Practically very difficult.
No. What do you need to do? we need to have a chemical treatment. So once you cool it down, then you have to use the sulfur recovery, HGV plant.
That is because this system is costly. So the plan we have to add a few more like this capture system for salts and noise.
Yes, we have to remove salts and noise.
So if you are talking economically,
Yes.
it will be very costly.
Yeah, that is costly.
So then, which option will be like some other countries they are going on?
See, what it is just like risk path, risk resistance path. When we talk about the electrical circuit or communication circuit or yes circuit, always we choose the path of risk resistance.
What I am asking is practically, I think India is not continuing. No how can we with like this system?
Then we have to condition it.
So some other countries they are following.
And they are already doing it.
And that is method.
No, they are actually doing it, cleaning out the gas.
And that's not cleaning, they are cleaning.
Cleaning and removing the sulfur, then you have a NOx recovery. Then you are doing it.
Total system will be. Total system will be that like this.
Yes. It will be without that you can even, because CO2 then reacts back. It cannot be done. And the thing is that it's more difficult. Like it's not that on this you are putting it on the ground, and then you are putting in a geological formation where CO2 is not reacting with that next layer, and even if reacting, it is forming the minerals. You cannot afford any of the other chemicals reacting this, because last time we discussed after the drilling of the well, during the drilling of the wells, you need to cement that. And this cementing process needs to be continuous. So this 2 kilometer long hole, once you cementing it up, it must be a continuous cementing process. The whole thing. What happened during some political situation, the trucks could not come, which is it's a ready mix concrete. You put it down and it's a concrete. Because they couldn't come in time, and there was a crack in between the cement. So what happened? There you had a penetration of water in a long layer. And immediately that layer started water and it started reacting. And the whole village, more than 1 kilometer radius, they have gone down. It's a huge accident where there is a cavitation under the ground and it's going down. So it's very risky, very difficult. So we cannot really go, but even the first video we talked about, you have to be very sure that what is you are putting in the ground and it constantly reacting. So your CO2 should be really pure CO2. You cannot afford NOx or something like this.
Thank you.
The end of that it is capturing carbon dioxide. On the oxy-fuel combustion, what we are here increasing the percentage of CO2 in the flue gas.
What is really exactly what is getting recirculated?
Pardon?
I want to know what is exactly recirculating in oxygen combustion. When the whole carbon dioxide is captured, the idea of recirculation, flue gas recirculation is not coming out.
No. Again, you are not doing the 100% recirculation.
No,
His question is,
You need to have a certain amount of air-fuel ratio in your order. The CO2 you are putting in. I think why don't you let us work on this. We are, it's very difficult to work on that board and speaking out. Why don't we work on a pen and paper? With the equations coming in and it will be much better.
your question is very valid in the sense that theoretically, the carbon dioxide should capture it and put it down. Is it right? Nothing is in oxy-fuel combustion. What we are doing is we are burning it in oxygen and fuel only. So whatever we get is carbon dioxide. So why are you recirculating it? Is that your question?
Yes, that is the question I asked before.
Sir, exactly what I meant was, after burning,
Power is decided back.
the whole food gas going towards resurfacer, salts and mass almost getting reduced, and after that, what is exactly remains majority is carbon dioxide and vapor.
No, actually, your question, I understand what is. Let us see his face and these things, it will not be able to. Will not be able to. I think you are asking a very mathematical question, let us work on mathematical answers.
See, the thing is, what makes the lunch very, very tasty is your hunger. If you become hunger, the lunch will automatically become tastier. So let us make ourselves a little bit hunger. Is there any other question?
Sir, maybe that time to close the force, you were putting down the carbon dioxide.
Yes, sir.
The answer for is clear. Right now we know that under ammonia. So as an inert gas, naturally we are injecting nitrogen. So we are taking part of the CO2 that is produced and injecting again back to the combustor. It acts as an inert gas.
No, sir, I do appreciate
That is the reason.
I think, there's a lot of question I'm having the entire.
What is there to balance? Chemistry balancing I am not able to understand. Part of the CO2 is taken back as an inert gas to reduce the temperature. It acts as almost nitrogen. That's all. That's what I already in literature.
Sir,
What is the question? What is the question?
My colleague's question is, you are...
No, his answer is, let us not talk like laymen. Let us talk in very vague and general terms. Let us do the exact calculations and see what is the definition. You say that materials are not available. There are materials available, but the cost of materials will be very high. Wait, sir. What he's saying is, there is a lot of work to be done in this particular area. If you sit and do it, conceptually some solutions, some access can be given, but we have to sit and do it. That is what his answer is. And sir, will answer to him.
Sir, when we say the hydrogen, the N2 is separated to N%. So now it is combustible along with carbon dioxide. That is the reason.
You are saying nitrogen.
Nitrogen. Nitrogen is a combustible gas. I have tried to discuss it. So at 80 degree temperature, nitrogen gets separated. N into N%. So it becomes active. When this nitrogen becomes active, it is combustible along with carbon monoxide and carbon dioxide, not with oxygen.
Sir, I am having the whole technology I am with me. If you want, I will give you. I'll show you. I cannot give you. It's a $6 billion project, so I cannot give it to you. But I can show you with me. And later, this is we are talking mathematically. Let's talk mathematically.
Oxygen, we are burning not the carbon dioxide. With oxygen also we are burning. Oxygen is very essential element of the atmosphere. Here, later it is going to be completely permanently depleted of this oxygen. So, do you expect any imbalance?
Since I am not absolutely right. Let us give it a thought. I don't have a good answer.
Theoretically correct. Assume that the amount of oxygen we are burning would be lesser of maybe negligible, but we need to cross check it out. And this is a very good question. We will
I don't have an answer.
But I think the amount of carbon dioxide we are going to burn when compared to what is available in Mother Nature is slightly, possibly very small. That's what I think, but I do not know. We'll have to verify. Theoretically, a very good question. One of my duty, that is the entire group has to be divided into groups in order to make you present. To understand how difficult it is to stand there and explain those plays and make a presentation and defend your thesis, right? So the entire group has to be divided into, let us say, around how many groups you do? How many numbers you have? 35. How many it's 20. 6 groups, 6 people in a 5, let us say 5, 8 groups. So can you repeat 1 to 5 again and again, please? I know friends are sitting close by. So 1, 2, 3, 4, 5, 2, 3, 4, 5, please 5. 1, 2, me 5, 5. Me 5. You are 1. 1, 3, 4, 5, 1, 4, 4. 5. Anybody escaping? Don't play back with the tire play it over there. 1, 2, that's all. Now, who are the ones? Please, once please raise your hands. Please meet the ones, please. What? There is another one here. Please raise your hands. So these are the ones you can meet somewhere here. We will keep a placard this one here. Twos, please raise your hands. Yes. Threes. Thank you. Threes. Thank you. Fours. These are your common denominators. Fives. Do they have 6.5? So we will put the placards here. Finish your lunch as early as possible and carry on your discussions tomorrow evening. Tomorrow we'll give you a 45 minutes or half an hour to 45 minutes depending upon the time available. Give your discussion slot, and after that you are required to make your own presentations. And what do you think? How we can contribute the knowledge network in this particular area so that we can carry it forward. Is that right? Any questions on that? If anybody asks me questions, I'll answer that. Any fool can ask a question, wise man cannot answer it. Thank you very much. Thank you very much. Please enjoy the lunch.